Welcome, everyone. We're just now opening up the webinar and allowing folks to join in. We'll give people just a minute or so more before we get started, but thank you for attending. And we have an excellent presentation for you today. So just give us a minute or more to let everyone in, and we'll get started. While we're waiting, it really is an exciting period of time for IWCS. We're only a few weeks away from our conference in Providence, Rhode Island, and the program has really come together nicely and really is shaping up to be a fantastic event. So we hope you're going to be joining us in Providence. Please go to our website and you'll see the final program as is uploaded. You can take a look at it online or download it, but it's an excellent program. And again, we appreciate your support and participation. Again, let's just give another minute here. All right, well, listen, why don't we go ahead and get started? If there are a few late folks joining, that'll be fine too. But again, welcome to today's IWCS webinar. My name is Dave Cadu, and I'll be your moderator for today's webinar series event. A few housekeeping items. Please note that as an attendee, you're part of a larger audience. So during the presentation, all participants will be in listen-only mode. And also, this event is being recorded. So if you or any of your colleagues wish to watch it, the video recording, then please go to our YouTube channel, and you can also get there through our IWCS.org website. We encourage you to submit written questions for Aziz, our presenter today, at any time during the presentation using the chat function on the right of your screen. After typing in your questions in the space at the bottom of the chat, make sure to hit the send button, and your questions will be addressed, time permitting, at the end of Aziz's presentation. Our IWCS webinar series event today is being hosted by the Cable and Connectivity Industry Forum. And today we welcome Aziz Vahara. He's a staff engineer in the high performance polymer group within Arkema and located in Pennsylvania, USA. Aziz Vahara currently works as a staff engineer for Arkema. He holds a Master's of Science in Material Engineering and a Bachelor's in Chemical Engineering, both from Drexel University. Aziz has 11 years of experience with fluoropolymers, particularly with PVDF, for use in various fields, including the chemical processing industry, wire and cable, water filtration, 3D printing, energy storage, and fuel cells. Aziz is based at Arkema's North American headquarters in King of Prussia, Pennsylvania. So we welcome Aziz to today's event, and thank you, Aziz. Carry on.
Good morning, everyone. Can you guys all hear me?
Mm-hmm.
Yes?
Yes.
Perfect. Thank you, and thanks, Dave, for the nice introduction. As Dave mentioned, I'll be talking today about new advancement in PVDF material. PVDF. Second. Yes, PVDF is used in wiring cable industries for years because of its unique set of properties, flame and smoke, extremely high weatherability, flexibility, and many more. PVDF offers a wide range of properties from stiff homopolymer with high tensile strength to a copolymer with the lower flex modulus and better flexibility for cable design. It also offers higher temperature rating of 150 degrees C due to its higher melting temperature. And it also offers better low temperature impact resistance down to -25 degrees Celsius. PVDF is inherently fire resistant, but it also comes in plenum version with a smoke and flame suppressor. In today's topic, we will talk about new advancement in the PVDF polymer, which will talk about few case studies where we will looking at PVDF for extreme low temperatures down to -60 degrees Celsius for impact resistance. We are also looking at PVDF in the use as high with a temperature rating of at 200 degrees Celsius via cross-linking. We're also going to talk about a new standard introducing that to ASTM D 8436, which is for material selection for the encapsulation of downhole cable. And we will also talk about the new addition to UL 1581 for improving flexibility selection of material for flexible cable designs. So we'll start with the first case study where we look at PVDF for extreme low temperatures. PVDF has good low temperature properties. PVDF copolymer can pass Mandrel rep test down to -40 degrees Celsius. Specific PVDF polymers copolymer can meet an impact down to -25 degrees Celsius, like Kynar Flex 3030 and 3120. And it's been difficult to achieve impact resistance below -25. And in this specific application, we were looking at cable design that needed impact resistance to -60 degrees Celsius. It also needed flexibility as these cable needed to be wrapped around annular structures, and high temperature rating as it's actually heated cable, so it needed to be heated. So it needed high temperature rating for that as well. As part of this study, we looked at few characteristics of PVDF as a driver. So we looked at comonomer ratios. The reason comonomer is important is it defines the flexibility within polymer. The higher the comonomer ratio, the better the flexibility the product has. Along with that, morphology, how the polymer is prepared, has a big impact on how the low and high temperature property of a polymer will be. So we looked at specific morphology, in this case, heterogeneous and impact modifier, as traditional PVDF is getting harder to meet those requirements. We looked at impact modifier that are compatible with PVDF and low enough TGs that we can able to achieve those -60. So for this studies, we looked at two PVDF comonomers with high and medium HFP comonomer ratio. As I said, we only picked one recipe, heterogeneous morphology for this. The compounds were prepared with and without impact modifier. And for the test protocol, we used the ASTM D638 for tensile testing, ASTM D790 for flex. And for low temperature impact, we had two methods. We looked at IZARD impact testing for ASTM D256, where we defined the ductile brittle transition temperature as 50% drop in energy. And the way we do this test is we take the bars, we condition at various temperatures, and we measure the impact energy. We then take those impact energy, plot as a function of temperature, and where we see 50% drop in impact energy, we define that as a ductile brittle transition temperature for the material. In addition, we also did testing for cable impact, and we do low temperature cable impact testing, and for that we made a cable using 4 twisted pair core. The reason we selected that core was tougher to pass, so we chose one of the worst case scenario. We jacketed that cable with a 20 mil wall, and then take those cable, condition at various temperatures, and then tested for impact using the fixture shown here. The fixture has a 6 inch of height at the fall and then 1 kg of weight. We did 2 impact per each location on the cable, and we did total of 9+ impacts in order to get the results. And for this, we defined the ductile brittle transition temperature as the lowest temperature at which we saw 50% or less sample exhibiting no break. So here are the results from the study. As we can see in the table, we saw very minimal effect of the impact modifier on the mechanical properties. We actually saw a slight improvement in actually flexibility. We saw better, the product got a little bit more flexible. In terms of CP1 or CP2 composition, CP2 composition or copolymer 2 with impact modifier, we were able to meet the UL 1581 requirement for the -40C cable. In addition, what we found is, again, the twisted pair cable was tougher cable design. We found that in actual cable design, we were able to pass -60 impact using this compound as well. The compound with impact modifier had even better flexibility improvement, and the impact resistance was even further better compared to the CP2 composition. We're going to talk about next case study. In this case, we are looking at PVDF for use at 200°C rated cable via cross-linking. So PVDF materials are, again, has a temperature rating of up to 150 degrees Celsius because of their limited by their because of their melting point. They can be cross-linked via e-beam e-beam radiation, and which will allow to use the product up to 175 degrees C, which is a class E cable for the ISO 6722. Any higher temperature rating than 175, what we have found is that limits by the thermal resistance of the material, and we also see embrittlement in the material's property. So it has been difficult for conventional PVDF to achieve a robust 200 degrees Celsius rating, which is the class F per this ISO 6722. As you can see in this class, if you are rating at class F, if it's 200 degrees Celsius rated temperature, it needs to be, for short-term aging, it needs to be aged for 240 hours at 225 degrees Celsius. So for this study, again, we looked at specific parameters. One of them was comonomer ratio. Again, comonomer ratio defines flexibility of material. Along with that, it has another effect of cross-linking. It actually improves cross-linking efficiency due to presence of comonomer ratio. We also looked at targeting viscosity. We found that high viscosity products are better at cross-linking. And in addition to that, they provide better creep resistance. And again, morphology, as we mentioned before, or as I mentioned before, improving, it defines the low and high temperature property. So we wanted to start with a good high temperature property for this product. So we selected morphology as one of the variables as well. So for this study, again, we looked at 4 copolymers. We had 2 HFP levels, comonomer levels, medium and high. We looked at 2 viscosities, medium, high and low. And we looked at 2 morphologies, homogeneous comonomer and heterogeneous comonomers. All of this compound were compound with 3% TIC, a cross-link promoter, and the cable made using this compound was radiated with 10 megarats of radiation. We test using the ISO 6722 for class F cable. Again, as I said, for that one, we had to heat age at 240 hours for 225 degrees Celsius, and at 3000 hours at rated temperature of 200 degrees C. The test calls for manual wrap test at -40 degrees C. For this test, we added low temperature impact because we truly want to differentiate the performance of the cable. So we also follow the ICE test standard at -25 degrees Celsius. Again, we use 4 twisted pair core cable. Again, was one of the harder, so that's why we decided to choose that core. We again did 20 mils jacket on that core. And then those jackets, those cables were refrigerated at negative 25 degrees Celsius for a minimum of 4 hours. And then after the 4 the cable were taken out and tested through impact using the text picture shown in the image here. Again, we did similar to the last test, we did 2 impact location or 2 impact per location, and we did total of 9+ impacts on the cable. And in this case, we defined break for the sample as greater than 50% sample exhibiting break. So here are the results. I wanted to emphasize manual wrap test. All PVDF sample passed manual wrap test, so we couldn't really differentiate there. But again, that's why we chose the low temperature impact. And you can see the only sample that showed no break was the copolymer, copolymer 3. That is high HFP, high viscosity, heterogeneous recipe that has the best after radiation and heat aging, no break. And the other thing I want to point out that looking at the other results, what we have also discovered with that test is the short-term test is not as aggressive as it's more aggressive than the long-term test of 3,000 hours. So again, as I said, the higher temperature, shorter term is a more aggressive test to pass. All right, we're gonna talk about the new ASTM D 8436 standard for encapsulation of downhole cable. This is a new one-of-a-kind standard for selection of fluorinated polymers for use in encapsulation of downhole cable. In this type of a cable are used in downhole application for encapsulation that's shown in the image that protects the interior components. As the purpose of this encapsulation is to protect the internal components of it. And what we find is that encapsulation material in this goes through aggressive chemistries. It is exposed to mechanical stresses, extreme weathers, and if improper selection of this material can lead to premature failure of this cable. So this standard was written in order to select specific material based on properties. So it defines general properties needed, and then it also defines minimum requirement for that properties on the cable. It also talks about retention of physical property on aging. Because it goes through aggressive chemistries, we wanted to see the effect of retention of those mechanical properties after exposure to diesel, sulfuric acid, extreme weathering condition as per ASTM D 7869, and also after thermal aging. So for this study, we looked at 3 Kynar PVDF grades. All of them are copolymers. And we went through gone through that test protocol using these 3 materials, and what we find is we see that Kynar PVDF meets all the requirement. Weight gain is less than 1% after chemical exposure. In addition, we see no significant mechanical losses. We actually retain more than 85% of the property after exposure to those aggressive chemistries. Upon weathering, we did not see any cracking or surface grazing on the sample. And we also see no mechanical property losses. We actually retain more than 70% of those properties. And we were able to rate the product at 250 degrees Celsius, which was for this test, we actually aged the material at 159 degrees Celsius, and you can see we did not see significant losses in the property there as well. In addition, Kynar PVDF has inherently RTI rating of up to 150 degrees Celsius. It also has inherent UL 94V0 rating and has naturally high LOI values. All right, the last thing on the list. So we had new addition to the UL 1581, a standard for electrical wire, cable, and flexible cords. In this, there was a new category of new category material was added to UL 1581. This category allows for use of more flexible copolymer PVDF with improved flexibility, low shrinkage, and shrinkbacks, which is desirable for the fiber optic cables. Has higher impact resistance at low and high temperature, at room temperature and low temperature. The reason the addition was made, it allows you to design more flexible cable without losing other or retaining most of the other useful properties for the material. Summary, PVDF for extreme low temperature, PVDF composition with modifier can resist the cable impact down to negative 50 degrees Celsius with improved flexibility and strength. PVDF able for cross-linking, as we found that PVDF heterogeneous grades with high HFP and viscosity are efficient at cross-linking. They are able to provide temperature rating to about 200 degrees Celsius with lower radiation doses. And then PVDF, crosslink PVDF cable will, with this type of a composition, can be rated for class F for the ISO 6722. Again, the ASTM D 8436 selection of material, only standard for resin selection for downhole cable that are exposed to aggressive environments. And PVDF passes all the requirement per those standards. And then again, addition to the standard UL 1581 allows you to use more flexible PVDF copolymer for cable design that requires flexible cable designs. Any questions?
Azaz, thank you very, very much. A very interesting and useful material. I think you're evolving for many different applications. If there are any questions for Azaz, please make sure to enter those in the chat, and we'll address them to him as time permits before the end of the webinar. Azaz, you didn't address some of the dielectric properties, but I can imagine that, with the connections across a number of devices in, a smart society and smart community, where data cables or even some limited power PoE type applications go outdoors and to cameras, to any number of devices. With the chlorine molecule, obviously, causing a little bit of a detriment to the transmission properties. Do you still see PVDF as a jacketing material for, limited energy, limited data that
Yes.
Goes out to devices?
Yes.
Because
So
it's great.
PVDF material would be a great material for that purpose because again of the high temperature property that it brings. It can be used with low power communication cable PoE, and it's an excellent choice of material for that as well because it's able to retain most of the thermal aging property is the main driver for that application.
Yeah. And not only, lower levels of data, got to go out to a security camera or what have you, but I would imagine in industrial environments where, signals and again, limited data, to control devices, pumps, whatever. Do you see a large application for PVDF jacketed cables in industrial or in addition to downhole type environments?
Yes, yes. I mean, for communication cable, I mean, again, if you are in an industrial application, especially indoor, outdoor, plenum space, and even external application, again, the plenum additive allows for the plenum application, but also the weatherability of material allows for external industrial use. And again, with low shrinkage, it helps with the communication cable, copper or fiber optics. So fiber
Yeah,
optics is the cable where it really drives the communications, and I think it's the best material of choice for that.
that's a great point. Optical fiber would be an excellent point, with the transmission issues, but, being
Yeah.
light, it's not a problem. It was noted that using HFP comonomer improves the cross-linking. What does this actually mean? Is it cross-link density or purely determined, by performance?
It's a cross-link density because the comonomer drives amorphous structure. The more comonomer you have more amorphous, and crystallinity improves in amorphous region upon radiation. So that's really where we see an improvement because of the comonomer ratio. We see higher amorphous region, and that amorphous region now becomes crystalline, and that improves the cross-linking density.
Yeah. What are the processing requirements for extrusion of PVDF? Temperature ranges, any particular, corrosion resistance
So
or any type of alloys necessary, special equipment requirements?
So one good thing about PVDF material compared to other fluoropolymers is you do not need specific tooling for processing PVDF. You can, because of its lower temperature and wider processing temperature windows, it can be used in a traditional machines that are designed or uses PVC, polypro, and similar type of machines. It does not have any specific requirements for that reason. And yeah, that makes it versatile because it can be adapted to larger machine types.
Yeah. And, are these PVDF materials, in some of these specialty grades, are they available in various regions around the world, or are they manufactured just in the US?
So most of them are manufactured in the US, but we do have global production. So some of them are, but again, depending on the market needs, we we can make in different regions, but it can be shipped to other regions as well. So all of
Sure.
this, some of these materials are developmental materials, even though they are um, mentioned here. We have run some materials on a plant, and they are easy to commercialize as well.
Excellent. Well, I see no more questions. So again, we wanna thank Azaz for bringing this excellent information on these materials. Very useful in our growing connected environments, indoor, outdoor, and PVDF will play a major role in these cable products going forward. So again, thank you. Um, I am providing Azaz contact point here so that in case you have any questions you want to reach out directly to Azaz or any of his colleagues at Arkema, you can reach them through Azaz. And again, I want to let you know that this webinar has been recorded and will be available. It normally takes just a week or so to get them uploaded, and you can find all of our previous webinars there as well. The IWCS webinar series conducts these technical paper presentations each month. And sometimes we also have some sponsored company information as well for suppliers to spotlight their innovations. Our next scheduled technical paper presentation event will actually take place in November. We're going to skip October because it falls right in between, right during our conference coming up. But we typically provide these technical webinars on the third Friday of every month. So November 15th will be the next. Each of you will be receiving announcements for these events. So please feel free to share our announcements with your colleagues so that they can join in and register as well. And again, we want to thank Azaz for being part of today's event. Azaz actually presented this paper at our last conference in Orlando. And in fact, beginning in November, we will start with a new series of papers coming from this year's event. So you'll be seeing some interesting topics that are going to be covered in Providence, Rhode Island. It's important that we all recognize and thank our partner sponsors who greatly contribute to the success of the Cable and Connectivity Industry Forum. Without their strong leadership and generosity, we would not be able to bring these important technical innovations and information to you and our global community. Today's webinar and all of our webinars have attendees from all over the world in all of the continents that participate in the wire and cable industry. So again, we thank these leading suppliers in our industry for their support. And for over 72 years now, the IWCS Cable and Connectivity Industry Forum will take place in Providence, Rhode Island. We are the recognized leader showcasing new technologies and cable and connectivity products, processes, applications. And the next event will take place in just a few weeks, October 14th through the 17th. In Providence, Rhode Island at the Rhode Island Convention Center. So if you haven't received already in your inbox the announcements, please go to our website to learn more of the exciting program that we have. We have the final program now posted, so you can review all of the technical papers and the content. And some amazing information is going to be discussed at the conference. So we hope that you'll attend and participate to hear and to network with your colleagues from around the world. So again, we want to thank you for participating in today's webinar event. We hope you have a great weekend and hope to see you in Providence in a few weeks. So thanks very much. Take care.